What does the rate mean? What is the rate? Give me an example of a rate, Marlia. How fast you're going? Like 60 miles per hour would be a rate. So if you would think about it, Raven, and you'd say, okay, if we were going 60 miles per hour for 4 hours, what would our distance be? 240 miles. 60 miles per hour times 4 hours time gives us the distance of 60 miles. Okay, right? Okay, so let's take a look at a couple of examples. And a lot of this, comes down to how we're going to set things up. And that's, a lot of times, that's the major battle. How are we going to set this up? How are we going to organize the information so it's easier for us to see? Bill Albers rides his bike at a speed of 14 kilometers per hour. How long will Bill take to travel 42 kilometers per hour? So we'll use that formula. Distance is equal to rate times the time, and we'll fill in the pertinent information. 14 kilometers per hour is what? D, R, or T? R. And travels 42 kilometers, is that D or T? 42 kilometers is time. Right? So let's put it in the right place. Then we have this as what's left. Well, that's what we have to find out. That's the question. That's the question. Okay? So in order to get T by itself here, we'll have to do what? Divide both sides by 14. Okay? That will get T by itself, which is what we need to find out. And then mark 42 divided by 14. 3. 3. Okay? In this particular case, yes, it would be 3 hours. Try exploratory. Number 1. Just try the first part. D equals R T. What is it that we know? Yeah? Okay, what was D? Look at it, Raven. 80 km slash H. What is that? Kilometers per. So what is that? Is that a distance? Oh, from about here to Chicago is about, 100 miles per hour. Kilometers per hour. Well, if it's not D, is it T? So you've got social studies class at 9:45 or 10:45 kilometers per hour. I'm just asking. What does it have to be? What does it have to be? The rate? The labels will help you recognize what they are. Okay? The labels will help that. Then, 6 hours. Distance or a time? Time. 8 times 6 plus the 0. 480 what? Kilometers. Okay. All right. Very good. Now, example number 2. Your favorites. Charlotte and Stan leave Grenada Hills at the same time. They travel in opposite directions. Charlotte at 75 kilometers per hour, example 2, and Stan at 80 kilometers per hour. In how many hours will they be 620 kilometers apart? Now, you've seen problems like this before. You've seen them on tests, more like standardized tests. Maybe you see questions like this when you test for high schools and things like that. Let's try to set things up. In your mind, you can kind of see what's going on. They're both leaving the same location, but they're traveling in opposite directions at different rates. Okay. They want to know how long will it take for them to be 420 kilometers or 620 kilometers apart. So let's set up a chart, and what we'll do is we'll set it up this way. We've got Charlotte, and we've got Stan. And R times T is going to equal D. D is equal to RT. Is that the same thing? R times T equals D? Yeah. All right. So I know that Charlotte's rate is what? 75? And Stan's rate is 80. Do we know how long? Or is that what we're trying to find out? We're trying to find that out. So here, we're going to put a T there because we don't know. That's the question that we're trying to answer is how long will it take them to be this distance apart? When I multiply R times T for Charlotte, 75 times T becomes 75T. When I multiply R times T for Stan, 80 times T, 80T. I still don't know what T is. So what we'll do then is we will combine those speeds, those distances. Charlotte's at 75T and Stan's at 80T to get our 620. Do we have like terms in which we can add together? Yes, we do. 75 plus 80 should give us 155T equals 620. Divide both by 155, and we're looking at 4 hours. Now, what I want to do for today, because we did miss class yesterday with the program practice and everything else, and we're going to miss essentially Friday, is there's going to be, if you look on pages 176, 177, there are two problems there that deal with uniform motion. Throughout our review these next couple of days, we can get to solving some of those. I want to go back a little bit and start at 6-1. So we're going to 176, page 176, and I'm going to have you guys start working on the review. Okay. Now let's take a look at some of these section by section so that we remember, because it may have been a little while before we did some of this. Like numbers 1 through 6. State the degree of each polynomial. Now remember, to find the degree of a monomial is when you add together the degrees for the variables. To find the degree for a polynomial, it's the one that has the biggest degree. So look at number 1. 17 minus 4a to the third. to what degree is the 17? Does the 17 even have a variable, Marlia? Does it even have a variable? So therefore, its degree is 0. What's the degree here then? 3. Which of these is bigger? So our degree of the polynomial is 3. Okay. What about for number 5? The degree here of 2xy, 2, right? Because 1 with the x, 1 with the y. How about with the 3x? How about the 5y? 2. Not 4, but 2, because we go with the biggest one. Okay, remember that a little bit now? Good. 7 through 10. Arrange the terms in each polynomial so that the powers of x are in ascending order. Ascending means what? Ascending going up, which would mean least to greatest. Very good. So let's take a look at number 7 together. Okay. Least to greatest in terms of x, powers of x. So which one has the smallest power of x, Marlia? 3. And that's a positive 3, right? Followed by which one? Power of x. Kate. Negative 4x, because that is only a 1. Then Kate. X squared, because that's 2. And then finally, there it is. Remember that. Okay. And remember, it's only for x. For this first example, all we had were values of x. But when you look at number 10, for example, are you even paying any attention to the y squared in 3x squared y squared? Are you even paying attention to the y if they're asking for the powers of x to be in ascending order? No. Now, you include it when you write it, okay? You don't completely forget about it, but it doesn't factor into how you order them. So for number 10, which one would be the smallest? Negative 9, followed by negative 7x, y to the third, because there's only one x. And Marlia, the next one? And then obviously 10, right, x to the third y. Okay, remember that? Okay. So in 11 through 14 will work in a very similar way. Okay? Except descending would be greatest to least. Again, it's powers of x. Sorry, we're going to get some 5th graders. Because choir is singing for the funeral, and Mrs. Z is in the choir, adult, the senior choir. So we're going to get some 5th graders in here, so just do your best to ignore them. Maybe you can be good examples and show them how you're supposed to act in class. That would be huge. All right. 15 through 19, find each sum. 19 looks a little bit different, but that's only because why? Sure. Yeah. Wherever there's an open desk. I've got 1, 2, 3, 4, 5, 6 open desks. Great. 19 looks different. Why? Yes. It's just laid out vertically as opposed to being laid out horizontally. Do you want to try one of those? Okay, let's try one. Let's just go with number 16. Try number 16. Like terms, 5A, 8A, how many A? 13A. Positive 3B and a negative B. 2B. Negative 7C, positive 4C. Negative 3C. Okay, remember that? Yes? 20 to 24, find each difference. What is it, what is it that we did, and see if you can remember what we did that made it very similar to the problem that we just finished. Something about the additive inverse. Mark. No, we didn't make the right side all negative. We multiplied everything by -1. So that we could do what? So we can add. In order for us to add, we had to change the signs on what came after. So if this was a positive 3x, it now has to be a negative 3x. If this were a positive or negative 3y, now has to be a positive. And then from there, 7x and a -3 becomes 4x. Positive 2 and a positive 3 become positive 5y. Okay? Yes, additive inverse. It's like saying adding a negative is the same as subtracting. But if it's already negative, we're going to make it positive like we did here. Okay? Trying to think if that's a good start or not. Is that about half? Yeah, we should probably stop it. So let's do 1 through 24 for tomorrow. Page 176, 177, 1 through 24. And we did a handful of these together.